If you know anything about me, you know I love serverless. If you know anything else about me, you know I hate slow apps, which is why, ultimately, by the end of this year, I'm hoping to have moved off of serverless almost entirely. So what am I going to do instead? I'm not going to host servers, right? Well, you know better. I'm not going to host servers. I will never touch Kubernetes or Terraform or any of that chaos around provisioning boxes again. I'm just going to move everything to the edge. Well, why though? Let's talk about it. So the first thing we need to break down is, what do I mean by the edge? When we talk about edge, we're often talking about one of two different things. The one I'm usually talking about is the edge runtime, but there's also the edge location, which is running servers way closer to your users. When you use something like Lambda, you pick a specific location that the serverless functions run in, like US West 2 or US East 1. That location is where the actual server is spun up to run your code quick. And if you have users in other places, they're all going to be hitting that same server unless you create different regions and route traffic to those different regions. Generally, that's probably for the best because most databases are also in one region. But with Edge, you don't really think about regions. Things are distributed all around the world. There's, I think, like 200 plus different locations for edge functions on Cloudflare and many more on other providers too. And the benefit here is the function that is getting the request and sending a response is way closer to the user. That said, I don't care that much about global edge functions in terms of the location the functions are in. Edge, the infrastructure, is much less interesting to me than Edge the runtime, because Edge the runtime means I don't have to spin up a Linux box to run my code. With Edge, you have isolates that can run in parallel on a given box and easily take in code, immediately process it and respond, whereas on Lambda and serverless, you actually have to spin up instances using the firecracker chaos that Amazon invented a while back. And as incredible as that technology is, the isolates that you have with something like Edge runtime are much more powerful. AWS does have an Edge product they call Lambda at Edge. I want to be clear about this though. It is not Edge the runtime. It is just Edge the location. And it's not even really Edge the location because AWS has such a limited set of locations they deploy servers to. So when I talk about Edge, and I'm talking here now about moving to Edge, what I'm specifically most excited for is moving our functions to the Edge runtime so that we no longer need to hit cold starts to process requests and send responses to our users. One additional thing with Edge that makes it really valuable: cost. The cost of Lambdas is not cheap. It's not expensive, but it's certainly not cheap. You're paying per hour of time spent doing requests. Whereas with Edge, you pay for the number of requests, and the amount you pay is very small. On Vercel, for 1 million requests, you pay 65 cents. That is hilarious. The cost of doing things on Edge is insanely cheap. It's hard to do a one-to-one comparison because with Lambdas, you're paying per minute of compute, and how much compute you do per request can vary, but I promise you, it is hard to make a workload that is more expensive on Lambda than it is on Edge, and cost is by far one of the best reasons to move things to Edge if you can. And things like rate limiters and bouncers should almost never be run on Lambda if you can avoid it, simply because of the cost difference of running on Edge instead. But is this really worth it? What's the difference? What's the cost? Why am I even bothering making a video? Well, Edge has some gotchas. From the 1 megabyte limit in how much JavaScript you can ship to an Edge, to the distribution by default causing longer round trips, there's a lot of things we have to think about and worry about now as we use Edge functions. Let's talk about a few of those. Let's say we have a user, in this case a circle, and a database, in this case a square. And this big circle is the world. These two things are far distance from each other. That's not the biggest deal though, especially if the user only makes one request. But the user isn't going to directly request from the database unless you're using something like Asura. Don't use something like Asura. And as such, the user needs to hit a server. Generally, the way we deploy things most of the time, if we're doing things right, simple. So we have a server that's really close to the database. These two things are usually going to be in the same region. We'll call this US West 2. So when the user makes a request, the user hits the server, which can not immediately, because it has to form a connection, which can take some time, but it's in the same region. So once it's formed a database connection, let's say it has to make like 5 round trips because it does a query to see if you're authed or not. When we come back, you're like, yes, this user's auth, they can continue. So it's like, okay, they're requesting profile information for this room. Do they have permission for it? The database says, yes, they have permission for this room. They're like, okay, then we want the data for this room. At which point the database responds, okay, here's the data for that room. And if this database is nice and close like it is here, that's great. Let's say the server gets moved really close to the user. This looks pretty good because the user is much closer to the server and theoretically they can get a response faster. But you might have noticed the actual amount of distance traveled here has gone up a lot because there are more back and forths here between the server and the database than there are between the server and the user. So if that is the case, which it is on a lot of services as you waterfall your queries, the server being closer to the database is often significantly better than the server being close to the user, just by the raw amount of distance that has to be traveled by your network requests. costs. So if we have edge servers that are running all over the world, like we have tons of these all over the place, we have one in here, but we have one up here too, depending on where you're located and what that closest edge is, this can get really nasty really quickly. So how do we deal with this if we're using edge functions? Doesn't this look objectively worse? Well, thankfully, there is a very cool solution to this now called regional edge functions. Vercel's been pushing this pretty hard. I'm seeing more and more people taking advantage of it. The goal of regional edge functions is to take your edge functions and limit them to a specific region. So it says, okay, our edge functions can only run in and around West 2. And by limiting in that way, yes, the user is no longer getting the edge benefit of having the server really close to them, but the user is now getting the edge benefit of the cold start being milliseconds instead of seconds. That is a massive, massive win. But you now have to think about where this edge is going and not just put everything in the same region, or just do. It's fine. This effectively makes the behavior location-wise nearly identical to Lambda, which solves most of our problems. This is a project Vercel built to test the database latency for global edge versus regional edge with a bunch of databases in the same region, or not, depending on the database. So in this case, we're going to pick PlanetScale. Love them. They're a channel sponsor, totally transparent. And we can test the latency from a global function versus in a US East regional function. So the region's the same as the database. It's not making a database connection because it's using the HTTP proxy or HTTP endpoint. We'll talk about that more in a bit, but I want to show off what the implications are here. So if we run with a single query, so this is going to run one query from the edge function to the database and then get a response and time it. And we'll see that the global latency is a decent bit higher than the regional one for the processing time, which is how long the edge function has to run, because that edge function has to take more time to send the request and get back its response. But if we look at the end-to-end time, which is from when the request happens on the user's device to when they get a response, the closeness here is actually significantly closer because we've taken that one query and moved it from my device to the server. So the big difference here is this gap, but that time is still eaten by us as users regardless. But what happens when we change it to two queries? So now the edge is going to run a query, get some response, and then run another after using the data that it got in that first response. Things are going to look very different now. So we can see here with the two query example that the gap on the latency distribution for the edge versus us is gotten much wider, almost twice as wide. Silly, kind of makes sense though, because we've doubled the amount of queries that are being done. And as we see here, there are spikes for the global, but it's still not that big a gap. But we are now consistently seeing that the regional edge functions are fast. Actually, it's a bit bigger gap than I thought. It's like 3x pretty consistently, 2 to 3x difference between regional and global for your edge functions. So what happens when we bump it to 5 queries? When things get really interesting, and we're going to see a massive gap between the edge functions running in the region and the edge functions that are not. And this is pretty crazy because we're doing 5 back-to-back queries that are blocking on a function from the database, getting fresh data, and we're still getting a response back to the user in under 200 milliseconds consistently, under 400 pretty much always, which is nuts for doing that much data in a blocking fashion on a server of any form. This is insane performance. And to consistently be seeing numbers like this when we test using tools like this one and when I experience it with the things that we've built, regional edge is a really, really good solution to one of the biggest edge problems, which is also one of the biggest edge benefits, the global nature. So if the reason you're looking into edge is faster responses and better connection methods rather than the closeness to the user, here you go, problem solved. What's the catch? So we already talked about the region thing, and we showed you that it can be worked around, thankfully. Region proximity. It was PlanetScale is what I was testing with originally. Regional proximity solved with regional edge funcs. So what else? Compatibility. We solved the regional. Let's talk about the compatibility. The big thing to know about edge is it's not Node. So a lot of the things that you're used to using in the Node environment are not going to work. Things like built-in crypto methods, things like FS. You lose a lot of the stuff that we rely on every day. And even I've run into problems with some of our deployments where I can't use FS to read a markdown file to parse it inside of the deployment. And instead, I have to do a build step to get that file into the JavaScript world before the application ships on the edge. These are things that can be worked around, and we've been seeing more and more work done to improve this. In fact, Vercel just shipped a bunch of polyfills for different things, specifically buffer, so that packages relying on buffer will still work on edge. We're making progress here, but we're still making that progress. But there's something that's similar but not quite compatibility that's important to note. I hinted at it a bit there. I should say no native runtime layer. What I mean here is you can't shim out to C++ code or run some Rust binary in the background or do a lot of the other things that we're used to with everything from like Cypress to Electron to, more importantly, Prisma. And its current architecture, Prisma will never be able to run on the edge simply because Prisma runs a giant Rust binary that has to run on a real server. And you can't run that inside of one of the V8 isolates that exists within edge functions. So something like a traditional database connection where you're making a SQL connection to a database and maintaining that to send queries and responses back and forth, that can't happen on edge. That's just not an option, which is not just fine. It's actually kind of exciting because this has been taken as a challenge by a lot of the companies and individuals we talk about on this channel all the time. One of the biggest is our friends over at PlanetScale, who are actually the ones I was testing in this demo here. How am I using PlanetScale if I can't connect to the database? Well, they worked really hard to solve this. There's a library I've talked about a bit before, database.js by PlanetScale. And this library isn't necessarily interesting as a library so much as the infra behind it that powers what it is capable of. The TLDR of PlanetScale's serverless driver is that you can just post a request to an endpoint and get back a response. That post can just be a SQL string. So in this example, we await connection.execute, select one from dual where one equals whatever you pass for the variable here. It is a simple syntax to send SQL strings to a server and get back a response without having to form a connection. It is hard to put into words how awesome this is, and it's really cool to see all of the stuff people have been building on top of it, including the Keasley driver that is being used here, as well as the work that Drizzle ORM is doing to support all of this stuff as well. It's really, really powerful, and I'm beyond hyped on what I've been seeing. What is Edge? Edge is two things: Edge runtime and Edge location. Location for Edge is you run lots of servers in lots of different places. Runtime is you can spin up one of those functions and get a response out of it in milliseconds instead of seconds. These are different things. People seem to think the word edge means just one or the other. It doesn't. It's referring to both of these things, which is annoying, but I don't care about edge location anywhere near as much because any real application is going to have to worry about data on the edge, which means any real application is going to have to worry about where these functions are running, or they're going to do some crazy shit with distributed data, which is almost never worth it. And as a result, this becomes non-viable for a significant portion of the applications on the web. And that is fine. It doesn't mean it's bad. It doesn't mean edge location is never going to be useful to anybody. It simply means that we need to consider that edge means two things. And when I'm talking about it, I am almost never referring to this. So to be very clear, I don't talk about this much because I don't give a shit. So if you're trying to sell me an alternative edge solution that does just this and not this, I don't give a shit. I genuinely don't. I just couldn't care less. If we take a breakdown of a slow request on a T3 app today. So here is a request breakdown. So user makes a request, user receives response. What goes down on this line? And to be clear, we're doing this for a bad cold started request. So we're gonna say this takes 10s total because this is what it looks like for a bad case on like Ping or Kyle.com or any other Create T3 app. So the first thing that has to happen, and we will encode transit time between server and client in blue. So here is the time spent requesting to the server. It's all gonna be napkin math, but this is from what I've seen from tracing, playing with, and doing all these other things. So request to server is some amount of time. This is the bad case, so we're gonna be doing a cold start. So here, I'll fill this with pink for a cold start time. And then we have another thing here. Prisma spins up and connects to DB. Orange for things the server does. Request sent to DB and response received. And then there's like an additional render step, which is gonna be even. I'll make this a tiny bit bigger to be fair compared to this. Make this minuscule. That little piece there is actually render format output. And then the same time at the end here, send to user. Cool. This is a rough idea of the pieces that result in a request taking this long on a service like Ping today. You have an amount of time that the request takes to get to the server, a much larger amount of time that server takes to cold start if it's not warm, which there will be times where it isn't, period. That's the nature of building things on Lambda. You can never guarantee things will always be warm. That Lambda, once it's gotten all of its code and has everything it needs to spin up, now connects to the database. And once it's connected to the database, it can finally send a SQL request to the database, get the response, format, render, do whatever it needs to, be it send HTML to the user or send JSON to the user, and then actually sends it to the user. This is not the fastest thing. So what does this look like on global edge? So if you're going all in on Cloudflare, your edge is now global. Well, let's not do global edge first. Let's do the ideal. This is the regional edge. I will say 1S max because that's fair. So the first thing is this is going to stay exactly the same because the distance between the user and the server is much smaller, or is not smaller. It's exactly the same. So this does not get any smaller when you use regional edge. Regional edge Request to start's the same. Cold start time, it's not truly a cold start, and they'll fight. And I know there's going to be Cloudflare employees in the chat saying this isn't really cold start. So what I'm going to do to suffice them is I'm going to put cold start in quotes. Don't come at me. Next is connecting to the DB, except funny enough, this step no longer exists because we don't connect to the DB. We just send it a request. So this becomes there. And to be fair, this will be a tiny bit longer because it also has to sign HTTPS and like SSL cert check. So we can expand that a tiny bit. This will be exactly the same, and this will be exactly the same. You might have noticed this is a lot shorter now, like a lot shorter. Even though these blue things are still the same size, the actual traffic from the user to the server is the same distance. All the other steps have been flattened to be way, way, way faster. So what does this look like on the global edge? So the cold start happens. People are saying the cold start happens in the handshake. Cool. Here to make the nerds particularly happy, because like to be clear, the pushback I get, I want y'all in the comments of YouTube to understand what I go through when I talk to Cloudflare employees and such. Here's what they're asking me to do. They want me to specify that on the other side here, in parallel, an SSL handshake also happens. So as you see here, in this step that's so small it doesn't matter, two things actually happen in parallel. Do you feel better now, Jacob? Is this now accurate? Cool. Anyways, yes, your SSL handshake can happen in parallel to the edge starting up. Awesome. Regardless, we're talking 10 seconds to 1 second max here. And if you make multiple parallel database requests in here, this can get bigger and smaller, but it's not going to be based on, or it's not going to be exponentially bigger and smaller like it would be in the edge here. So let's do the next one. Copy this and paste it. So Jacob and friends at Cloudflare are advocating for with global is make this way smaller. Cool. Let's do it. We've made this way smaller now. So the issue here, I want to be very clear about the issue, is this request here for every database request we make. So we're assuming right now we're making one. All the time we saved here is now getting put here instead. So whatever the difference was, I mean, I guess we have the difference right there. It's that difference, but it's that difference twice because it has to account for the other side as well. And then finally, we got our response. So if we make a single database request, we have taken that travel distance as I showed in the diagram here. If we just make one request and we move the server somewhere else, is not a big deal. We've just moved who's doing most of the travel. But if we are doing multiple requests here, like will often happen in almost any service, then being closer helps a lot more. Because if we go back to the diagram here, let's say this does 2 requests. Every time you do an additional request, it doubles this. So if move these guys down, we do 2 requests. That's barely a dent on this. So you barely even feel it. There we go, 2 requests. And if we do this here, it's worth noting I made this bigger because we have to SSL handshake once. But once we've handshook, you could even argue that that's like a different step. So we could argue there's like the handshake step for the initial transaction here. I'm not going to label it because I'm lazy. But then all of these will be exactly the same as they were otherwise. And we end up with much faster overall responses still. But here's where the catch happens. If we use global edge, and I want to be very clear about this because this is why I think a lot of people push back on edge. And I think they have good reason. But we had this as the like additional time because of the distance. And we do 2 requests. It's a pretty massive difference because if this request took 40 milliseconds in the same region and over 100 milliseconds in a global region, you're going to be eating that for every additional request. And the result here is a significant full cycle penalty, as we saw in the charts here. This is pretty evident to me that unless you have data located on the edge alongside your edge functions, then global edge is net negative for a lot of applications. But that doesn't mean we shouldn't use the edge runtime. So what am I doing about this? Why am I talking about this now? And what does it look like for us to start moving to edge? Well, the first thing we have to do is handle the dependencies that aren't edge ready yet. The biggest one that we've talked about a lot is Prisma. I do want to shout out the team. I know they're working really hard to fix a lot of the things that make it hard to run on edge, specifically finding ways to run the connection layer on a different server so that you can connect to that through the edge function with a fetch request. That will significantly help, but we still have a lot of work to do before we're quite there. And in the interim, there are a lot of different solutions we have right now to start running things on the edge. For databases, we have Keasley and Drizzle, which are both phenomenal solutions. For auth, we have Clerk, which has been, after a little bit of nudging, gotten very edge ready, and they've been a reliable auth provider for all of our edge deployments. We have Upstash, which has a Redis connection layer that is fully edge compliant and compatible. And honestly, I'm not finding many packages now that aren't ready for the edge. Everything I use from Next to Keasley to Drizzle to Clerk to a lot of the stuff we talk about here, almost all of it is ready for the edge now. And as a result, the applications we've been building on the edge are just hilariously faster. I know I show this one a lot, but y'all might have played with the first app I built on stream a while back, Roundest. I want y'all to see how long it takes for the actual content to show up in the page. That was a pretty rough cold start. I didn't even have the network tab open, but that finished in 4 seconds for a hilariously minimal application. Pretty sad, but if we compare this to a different app I built, which to be fair, isn't fetching data from the edge to start, it's loading it in client, but the result is just hilarious. Like this is milliseconds now instead. And that like final chunk after, that's all from like Chrome extensions. If I go here and do it, 300 milliseconds, 200 milliseconds, or if I, what's the edge deployment for Chirp that I made? This is a deployment of a Mojer that appears to be broken, probably for people spamming content they shouldn't, but it is getting a database response in that time, and that database response is literally coming in 500 milliseconds or less, fetching a ton of data. It's sad the page is crashing. I'll go deal with that later. It's not a deployment I've played with much recently, but even like Marker Thing. Marker Thing's a new application that we just shipped that also runs on Edge. I guess it's not signed in at the moment. And you'll see the page response times are absolutely hilarious for fetching data and actually rendering it. It's insane. The response times we're seeing from things on Edge, no matter how much traffic they're getting, is just absurd. And like the latency that we're seeing is coming from whatever random JavaScript we're loading on the client, usually in this case, like Twitch's JavaScript. Yeah, things have been great. I am really impressed with the performance we're seeing. Overall, surprised at how smooth the adoption has been. And overall, just putting us in a place where we can take advantage of never, ever, ever eating one of these again. Theoretically, there's a future where cold starts can be mitigated by Lambda or things around it. But until we're in that future, I really, really, really would prefer to never have to worry about cold starts affecting my users again. Also, this one, because these two blocks tend to be where most of my applications waste their time running. And when a user doesn't get a response back in a second, it's almost always because these two things are holding them back. So if you want to make your applications faster and you want to keep using the awesome technologies that we talk about here, these are the problems that keep us from having that type of performance on serverless. We have to talk about one more small piece. How do I actually deploy this? There's 2 ways that I deploy it. One I like more than the other. Both are very much using Vercel and Next.js. The way that you can make any application on Vercel deploy on the edge is actually pretty simple. In your Next config, there is a runtime experimental edge. That said, Vercel does plan to deprecate this because they don't want us thinking about edge on an application level. They want us thinking about edge on an individual route level. The way they recommend doing this, and the way that I've seen it in most of their demos, has been on a given page, you export const runtime equals edge. And you can put node here if you have something that's incompatible with edge on just this one route, which means that on a route level, an API route level, or a page route, you're able to tell Vercel if this code should be thrown on Lambda or on edge, which allows you to have pretty hilariously granular control over how your applications are deployed. The result is just hilarious performance. I've been beyond impressed with what I've seen, but it's so simple to actually move your applications to the edge. I've been really impressed. If you're on other systems, there are ways to deploy. You're probably going to have to spend some time setting up Cloudflare yourself, though. To me, Vercel is the easiest way to deploy on Cloudflare's edge. So I use Cloudflare's workers edge functions through Vercel by adding a key here, or honestly, usually putting it here until they tell me I can't anymore. One last request from Vercel. I personally would really appreciate a way to opt all of my functions into Edge as the default runtime and have to opt into Node rather than the other way around, which is what it is now, where everything's Node by default and I have to opt into Edge. If y'all were down to make that change, or at the very least, leave this here for me, I would appreciate it, because I don't want to have to manually go through and declare Edge as the method of runtime for every single page route. Appreciate the help there. Super hyped on what Vercel's been working on here. I hope this one was helpful. I've been holding this one back for a bit, and this is why I'm moving off of serverless for the year and trying to focus all of my efforts on building great applications on the edge. If you want to hear more about what makes this database performance so important, I have a whole video dedicated just to database performance on the edge here. Check that out if you haven't already. Thanks as always. Peace, nerds.